Okay, now we've got these toolkit functions. Squaring function, the exponential function, and the reciprocal function. Open math is not going to tell you about the exponential function, but it's so fundamental. And if we want to talk about the usefulness of functions, the two functions that are most useful are this one and this one. I mean, if you need the others, they're useful too. When I say most useful, these are the two that have the widest range of applications for most people. Okay. The others are also important. And they do have applications, and we'll see them. All right. So we got the x squared function. What are the values that we use? Because we can square any of these values. In my instructions, I've said it. I said use these values where possible. Okay. It's possible to square every one of these numbers, so we're going to use them all. All right. Well, then we square. Well, that's easy. -2 squared is 4, -1 squared is 1. Is 1/4. Don't make a mistake. We're putting a negative in front of these because you got a negative here because you're squaring. -2 times -2 is a negative times a negative, which is a positive. I'm saying that not for your sake and not for anybody who's in the distance course this semester. Everybody in these courses knows that negative times a negative is positive. So I don't have to emphasize it too hard, but I sometimes use these videos for future classes. And I mentioned it, okay? -2 squared is -2 times -2, which is +4. Okay, so we don't make the mistake putting negatives. I see that a lot. 0 squared, well, 0 times 0 is 0. And then 1/2 squared, you know, what do I have? 1/4, 1/2 times 1/2 to multiply numerator and denominator. Multiply numerators. Okay. 1 times 1 over 2 times 2. Not saying that for your benefit, because everybody here and everybody in the business class knows that perfectly well. But often we get people who don't. Okay. And everybody understands, of course, it's explained. So if you are listening to this at some future date, make sure you understand and multiply for out. Okay. There are values, okay? And then we want to put them on a graph. Well, people generally want to take a graph and line off a piece of graph paper from -10 to 10 and from -10 to 10. That's what you do. That's almost every graph. And almost no graph that's important in the world fits on that grid. Okay? Still, when you're teaching, you know, there's a reason for it. When you're teaching math, teaching a lot of people who are pretty well struggling, and you give them something real tangible that does work to an extent. Leaves off your brightest speech. So I don't think it's a good idea. That's a debate. It's a political debate. It's an educational debate. It's a lot of things. And I got my opinions. But I'm not necessarily right. Okay. I am, but I don't try to talk. Okay. So oh yeah, there's -2. My top line is here. I was looking, where to put -2? There's no top line. Let's put a line there so I can find it. Okay. So -2, 4. Well, I've got a set of axes reasonably lined off. Okay. It goes from -2 to 2, which is the domain of this table consists of the x values we talked about the domain last time. Okay. remainder of this table fits these X values. And the range of this table includes the Y values. Okay, and that's the range, and they go from 0 to 4, right? So it turns out that if we use -2 to 2, we go halfway from -2 to 0 and get 1/2, and we don't need 3 or -3. Start on the table. If we want to put it in, well, if we got -2 and -1, we can find -3 pretty easily, right? I don't think it's necessary, but if you want to put it in there, it's okay. That's problem. As long as you got 1/2 in there and 1 and 2, 1/2, 1 and 2 in the negative, you're good. And I like to do that because it's easy to get the graph to a consistent scale if you know how to go halfway. Halfway from here to here gives you this. Halfway from here to here gives you this. It's the same over here. And halfway from 4 down to 0 gives you 2. And halfway from 0 to 1 gives you 1. And then you got these numbers down here, which, yeah, from 1 you go halfway, so there's 1/2, there's 1/4, right? Okay. I also often don't like labeling things right next to the axis. I kind of prefer to do something like this. I draw the lines, y equals 4, y equals 2, y equals 1. Y equals 1/2. And even 1 down here. Be careful to keep the scale reasonable. Y equals 1/4. Which is this lowest one. Okay. So I don't have to thunder up my curve with a bunch of numbers don't relate to they relate to the curve, but they kind of get in the way. And if they're out here, they don't get in the way. Okay. Many times in spreadsheets, Excel or something like that, they'll do this. They'll give you a box and they'll label the Y numbers over here at the left of the box, not on the axis, because then it's out of the way. So I kind of like to do this continuously. All right. I'm in my calculus class, and you know. Okay, so -2, x is -2, y is 4. And here's the x equals -2 line, and here's the y equals 4 line. They come together at this point. That's going to be the point for -2, 4. And -1 and 1, well, if x equals -1, and here's the y equals 1 line, so they go together here. Now we have the x equals 1/2 line. Now I think we get a little bit crowded. -1, and it has to intersect the line where y is 1/4, which is this lowest line down. Now, pretty close to the axis. 4 times closer to the axis than 1, right? And then we have 0, 0, which is the origin. And then we fill in the remaining points in a similar way. One of their problems is arithmetic sketch. They look at it on the screen and they see it still sucks. Okay. So, all right. Now, this is part of this graph. This graph, 2 to the x. Well, common thing that people don't do. And of course, open math, so you can use their calculator. I could slide it. 2 to the -2 means 1/2 squared. which is 1/4. 2 to the negative 1 is 1 over 2 to the 1, which is 1 over 2. Okay, these are rules of exponents. We've done the assignment rules of exponents, but still, negative exponents still tend to confuse people. Okay, well, don't let them do that because you really have to understand that. Okay, so when we do that, we get the number 1/4 and x equals -2 because 2 to the x is x -2, gives you 2 to the -2 that you just saw is 1/4. And 2 to the -1 is 1/2. And there's the calculation. 2 to the 0 is 1 because any number to the 0 power is defined to be 1. There's reasons for that. We won't go into it, but we'll calculate. 2 to the 1 is 2, 2 to the second is 4, and there are points. Okay, so we go ahead and put -2 here, 2 here, 4 here. Our domain goes from -2 to 2. -2 to 2. Our range goes from 1/4 to 4. Okay. Well, of course, we've got the x-axis there, so we're going to have to go down to the x-axis, but we'll go up to 4. So we could draw lines here and everything. But do this a little more briefly. Go halfway from -2 to 0, and halfway from there to 0, and I get -1 and -1/2. I have more room to do all the dotted lines and label whites. Okay, now you do the same thing over here, halfway, then halfway here. That's going to give you 1 and 1/2. Then we start dividing things here, same as we did over here. That's going to give us 2. You can't resist. That's still y equals 2. Different graph, but it was y equals 2 over there, 6 y equals 2. Y equals 1. Y equals 1/2 here. Y equals 1/3 here. And now we can easily locate our points. Okay. I try not to get in front of the board. I hope I wasn't blocked that too badly if I labeled these things. Okay. I don't get a lot of comments on my videos. Although, but one of the comments was, dude, you'd be standing in front of the board the whole time. That might be my favorite. I did a video last week. It got 200 views and 5 likes. I don't know what. I'm not trying to market these. But not even 1,000 subscribers. But people do watch these things apparently. I feel sorry for them. Now, okay, so what do we want? We want -2 1/4. Well, there's -2 and there's 1/4. Line y equals -2, x equals -2, intersects the line y equals 1/4 there. Okay, and then we have -1 1/2. Well, that's going to be here. And 0, 1, and 1, 2. There's 2 there. And 2, 4. Here. And then I was looking for 2, but I couldn't find it. 1, 2, that would be up here. Sorry. Okay. Still blind when you get that close to the board. My new glasses are in. I'm not going to bring them. I don't really need them. I got reading glasses and I can see fine through. So, not my eyesight, it was just my brain size. I was going to do that. Okay, there we go. Here. Okay, well, 1 over -2, -1/2. Get -1/2. And we got, yeah, at -1. And 1 over -1/2 is 1 divided by -1/2, which is 1 times -2 over 1, which is -2. Okay? And we really have to understand this in negative exponents. They kind of look the same because you got denominators, but they're different. Okay, so make sure you got these two rules down because they get in your way. And you don't understand. These numbers should be straightforward to understand. Okay. In this case, we notice that our x's go from -2 to 2. And our y's go from -1/2 to 1/2. Whoa, no. Y's go up all the way over in -2. You don't go from -1/2 to 1/2 just because those are the top and bottom numbers. Your biggest numbers occur toward the middle. So you got -2 here and 2 here. Well, then we've got 1/2, 1. So mark those off just as we did before. Okay. We do the same thing in the middle variances. Now that I marked these off, you ought to see why in pre-calculus class I had you construct the graphs the way you did. Okay, when you subdivide things, you start at the left edge, halfway to the middle, halfway to the middle, right? That's the right edge. That's the right. Okay. And here, halfway to the middle, halfway to the middle. And the same thing here. And it gives you all the points you need for this graph. And it doesn't give you anything extra. The only extra things you get are the lines you have to skip when you follow the rule for constructing this thing without any numbers. Okay? And you also know that I could make that rectangle any size and figure out what the numbers are and even figure out what the function is. Okay, that's where we're headed for these toolkit functions. The open math is going to give you some rules to use with toolkit functions. Your calculus is going to tell you why they always work, and you already started on that. Okay. All right. So that was a digression from my pre-calculus task. We'll get back to check on. Okay. So we plot them up. Okay. Now let's see. Here's where y equals 1/2. So when y equals -2, now we need -1/2. Y equals -2, we get -1/2. See what I mean about the numbers getting in the way? Okay. The y equals -1. X equals -1. Y equals -1. When y equals -1/2, x equals -2. And there's another number that's in the way, which is like the boundaries, but let's see what we got. Well, okay, and then we plot these. Get one here. One here. Now we've already seen this graph in my pre-calculus class because we constructed it without having to go through the confusion of all the rules you got to do that nobody ever remembers right, or very seldom will have anybody that gets them all right. Okay, so don't feel bad if you didn't. Your mistakes were minor. You understand that. These rules here, the rules that you got from the thing on exponents, okay, but kind of forgot already. So great for us. And a rule for dividing fractions, which we didn't. Okay. All right. Those are our toolkit functions. Toolkit squaring, exponential, and reciprocal. Okay. Now I took a lot longer than that. I really wanted to, but we want to make sure we understand the arithmetic involved these things because they're going to be doing algebra solving equations. Okay. Let's switch gears. We haven't yet talked about rate of change in your pattern. We did talk about, okay, if you make $80 in 4 hours, that's $20 per class, right? Okay, so, yeah, we did. So let's continue with that a little bit, because we have an assignment of that, and then an assignment on composite functions. Okay, and composite, both of these have some challenge, composite functions more than this, because people never listen to what I'm telling them. Well, it's actually because what I'm telling them, it's a little confusing, the notation. But they're not listening, it's just kind of hard to get into that sometimes. Okay. On rate of change. What does ROC stand for? Rate of change. How about WRT? With respect to. Okay. You know, we use that terminology last time, so it should be passingly familiar with it. And I'll keep saying it, and eventually it'll sink in. Okay. The only average rate is total y over total x, right? You might have done something like this. Let's say y changes from 4 to 12, and x changes from 8 to 16. What is the average rate of change of y with respect to x? So go ahead and see if you can work that out real quickly. I won't give you too much time, but I want you to have time to process it. Okay, now one of the most common things somebody in here actually did. Okay, but I see it all the time, so I address it. Okay, this is not. This is something to watch out for because I think in a pre-calculus class wouldn't be unusual 2/3 of the class to do something like that. Okay, so not y over x. Ignore that delta and you ignore the whole definition. Okay? There's definitely a delta there and a delta there. Now, what's delta mean? It means change in it. Okay? And if you kind of forgot what delta means, because we mentioned it last time, and I should have clarified it probably this time. But if you just kind of ignore the delta, you're going to get something like this, right? And you're not going to know what to do with two different things here. Okay? So the delta means change. In other words, change in because can't ignore it. Okay? And if you get that, then it becomes pretty easy to do, given this information. Well, the y is going to be 16 minus 8. You change from 8 to 16, then you change to 16 minus 8. And you break it down in steps. There's your average rate, which in this case is just 1. And it means whatever your change in x is, change in y is the same thing. If the average rate really applies, okay, everywhere between this point and this point. Now, we did this last time, let's do it again. We can put these points on a graph. Okay. We can say, okay, here's your point. 412, 48, sorry. Maybe I'll get it right. I erased it to start with. Watch, I'll get it right this time. Don't actually surprise, but that's right. Okay, 8, 4, right? Because x is 8 and y is 4. And then we have the point here, which is x is 16, y is 12. So this is the point 16, 12. If we sketch a horizontal line, then a vertical line, make a path from here to here, and how long is that horizontal line? 8 units. It goes from x equals 8 to x equals 16. We've got, here's our x equals 8 line. Here's our x equals 16 line. Here to here is 16 minus 8 equals 8. So with 8 here. Okay. And then going from here to here, we're going to have 12 times 4. Rise. This is the 9. The rise is your delta y, and the run is delta x. Okay? From this point to this point. So that the slope is delta y over delta x. It's the same thing as the average rate. Now, just said average rate. Whenever I have room, I'll say average rate of y with respect to x. Open math doesn't do a very good job of emphasizing that terminology. It's very important terminology. You got a calculus course in your future. And apply to that, which is fairly typical for some. Okay. Stay away from the engineering calculus unless you want to get really, really smart. Okay. Unless you want to really get challenged. It's a great course, but you probably don't need it unless you decide you want to be an engineer or something. Okay. That equals 1. A little box with that part of the rotation. Okay. Now, if you understand those two things, you have a good start on understanding what open math will tell you. A little less completely than it should, because we should be talking about the average rate of y with respect to x. Because what you're finding the average rate of depends on what the average rate of something with respect to something else. Okay. And for applications, it's very important. Understand that terminology and idea. Okay. Now I got to give you a quick introduction to composite functions. Your open math is going to give you a lot of other examples, but it's like the answer to that question. What's the reciprocal of the square of 2? No, what's going on with just commenting on the fact that people confuse square and square root. Fundamental mathematical concepts. People graduate high school, and half of them, probably more than half of the ones come in by pre-calculus. Anyhow, we'll get that straight. Okay, what's the reciprocal of the square root of 2? Well, okay. And if you wanted to do the numbers, which ultimately you would want to do. So you could write the reciprocal of the square root of 2 this way, or you could just do the calculation, right? But what you've done is you've taken a number and you fed it into the squaring function, right? Then you've taken that number and you fed it into a reciprocal function. Okay, that's called a composite function. You compose the squaring and the reciprocal. Okay, so we're going to just do that with function notation. But the idea is there are many times when you need to find some quantity, but first finding some other quantity. Okay, so you have to figure this thing out and then feed it into this thing. Okay, And you'll see examples of that as I don't have the time to do a lot of examples that we probably will next time. Okay. Here's how it looks in function notation, which is pretty simple. Okay. I'm going to build a symbols. F of x equals 1 over x and g of x equals x squared. What is f of g of x? So again, let's write it up here. F of x equals 1 over x and g of x equals x squared. So f of g of x, well, there are two ways we could write this. We could replace g of x with x squared, but I'm going to just do it one way. And what I'm going to do is I'm going to say, let's start with f. What's f of g of x? Well, you notice that up here I have x in the definition of f of x. Down here I have g of x, or x was, right? So x has been replaced by g of x. And I'm a little more folded. X in definition of f of x has been replaced by the expression g of x. So we're going to replace it everywhere in the definition of x. Well, if we replace it everywhere in the definition of f of x, what are you going to get? Here's your definition. F of x equals 1 over x. Replace all the x's by g of x, and what do you get? In other words, just take this, but instead of x, every place you see an x, you're going to write g of x. And you're going to write the equal sign and all the parentheses and everything. Okay? What does your expression look like? Okay, I told you this is a little weird until you see it. Here, what I mean is, if we got f of x equals 1 over x, right? And instead write a g of x, every place we have an x, what am I going to have? All right. This is a hurdle for people, okay? I can say this a million times in a pre-calculus class. 2/3 of the class is still not going to do it. So what we do is we relate, we erase the x's and we replace them by g of x's. Come back to record, yeah, I did. Okay. And this x is replaced by g of x. Now, some people saw through the whole thing. Okay, they didn't want to do this step because they were clever enough to see where it's going. Because if you want to do it, say replace x with g of x, you want on the right x squared, because g of x is x squared, right? Okay. Then over here, you would write 1 over x squared. So if you wanted to do this, and I said, no, come back and do this, you're just one step. Okay. But we want this intermediate step. Okay. So now f of x squared is 1 over x squared, because f of g of x equals 1 over g of x. Simple pattern. F of x is 1 over x, so f of g of x is 1 over g of x. Now g of x is x squared, so f of x squared is 1 over x squared. Now we often give this function a name. And usually I think you're going to see h of x, fgh. Okay. What it ranks of boards. I'll just tell you. The way that you'll see it in open math, that's the way the symbol. Open math is also going to tell you, okay, we're going to do the reciprocal of the square of 2. Well, you go to the table. Here is your reciprocal function. Oh, sorry, here's your square function. You're doing the reciprocal of, wait a minute, let's make sure. Yeah, you're doing the reciprocal of the square of 2, right? What's the first thing you do? Square of 2. So you do the reciprocal of that. Here's the square of 2. Okay. So it's like we start with 2 in this table, we get this number, and then we find this number hopefully on the table with the reciprocal function, but it's not there because we have 4 here, it could be 1/4. Okay. So you see several different ways to grasp the idea of a composite function. Okay. Notation is the one that tends to throw people more than that. If you understand what we just did, then you should have a good progress. Okay. Now, this won't be important for your pre-calculus course right away. Sometime next week, or maybe even early week after that, but it's coming up. Okay. And it's based on these, we're basing it right now on these toolkit sections. So get your feet wet with this assignment, do your best on it. And then when you see it in pre-calculus, you won't be stunned. That doesn't mean that you won't